Okay, my name is Cinderella. I'm from Austria, and today I'm doing the lecture on Cinderella, a prototype for a specification-based network intrusion detection system. Cinderella is my very own NIDS. I developed it on my own, and this talk I will explain what network intrusion detection is, and how it works, and what the most common methods are, and what Cinderella actually is, and how it works, and how it behaves, and how it can be evaded. That is very important when you talk about network intrusion detection systems. So, what's actually this intrusion detection thing? Networks are most often publicly accessible. For example, you have an SMTP server or web server or whatever, and they are under constant attack, mostly by script kiddies. And unused ports and services that shouldn't be publicly accessible are either turned off or protected by prefix filters or something. And you have the problem, publicly accessible services can't be protected by packet filters. And the solution is either use secure software, for example TGP or SCB installer, and I think similar, or use sandboxing tools like systrace. Intrusion detection is not about preventing attacks or protecting systems. In my opinion, network intrusion detection is about detecting attacks and benefiting from the information gained during the detection process. And so I put up 3 warnings and hints which are, provoking thesis in the area of network intrusion detection. And I think quite a lot of people will flame me. Well, first is network intrusion detection systems aren't turnkey solutions. There are quite a lot of vendors who assert that, and that's so a trap. Every NIDS has to be adapted to the situation where it's deployed, and that's quite a lot of work. And network intrusion detection system can't prevent attacks, and network intrusion detection system with any intrusion prevention mechanism is mostly crap, because most of these things are based on techniques that are not really good. Yeah. And network intrusion detection is not about getting informed who attacked which host by using which exploit. Many NIDS vendors make their intrusion detection systems so that they give you that information, but you maybe know this personal firewalls for Windows and stuff, they pop up and Nimble attack from host blah 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 on port blah blah blah. Who cares? I don't think you will have an IIS running, so it's absolutely not interesting. And everyone who wants such a system should install a blinking light on his or her desk that blinks whenever an attack was detected, so that this person is calmed down. But that's only placebo, and it won't help you anyway. Well, the 3 most common detection techniques I will explain is misuse detection, anomaly detection, or specification-based detection. The first one is the most obvious one. The network intrusion detection system has a set of patterns, and it tries to match these patterns against what is currently sniffed off the network. And first of all, it's very easy to implement, but it has quite a lot of disadvantages. The attacks must be known before they can be detected, and so unknown attacks can be detected. And when you do variations of an unknown exploit, for example, you change 1 or 2 bytes of an exploit string, it can't be detected anymore unless you have very good patterns. And So misuse, network intrusion detection systems based on misuse detection can be easily evaded. And of course, the set of patterns of attacks is going to grow, so the larger the set, the longer it takes to match the patterns against the traffic, and the set of pattern is going to grow. Yeah. Anomaly-based detection is, well, new technique or new area of research. It mostly uses machine learning techniques and statistical methods and stuff. And first of all, the system is trained how normal, good traffic has to look like, and all anomalies are marked as abnormal traffic, potentially suspicious or bad. And it has, well, several advantages. For example, unknown attacks can be detected, and no database of patterns has to be maintained. Disadvantages are the system must be trained with basically the same or similar attack-free traffic that will be accounted in live operation, and it has to be really similar to the traffic that will be encountered in live operation. And when too few features are trained, the system can't be effective. That's a problem with most machine learning stuff. So specification-based detection. The good behavior is first defined programmatically. And anomalies of this defined good behavior is not as bad. It's some kind of variation of that anomaly detection. But the difference is you have no training. Well, actually you do have a training, but the programmer is trained, and he maps his or her knowledge to the program. Well, some papers say it has a low rate of false alarms. Well, I won't judge about that. And well, Cinderella in our system implements some of these concepts. So now, a few facts about Cinderella. It's a prototype. That's very important, and it's not evolutionary. So Cinderella is going to be thrown away and be re-implemented. And well, it's implementing a specification based network intrusion detection. And the basic concepts are, the first one is in dubio contra reo. Does anybody speak Latin? That there is this in dubio pro reo in most modern laws, jurisdictions. So when a judge, the one who's sued is not guilty, and Cinderella implements well, in dubio contra reo, any traffic that cannot clearly show that it is good is automatically bad. And yeah, the second concept is thesis about attacks are irrelevant. This is already being implemented by other projects, for example Snort, and it won't help us anyway. Well, I try to keep the code base small and simple, so that it's easy to understand and reach, and easy to extend. And I also try to keep it modular. And yeah, Cinderella may act as a wrapper around another network intrusion detection system. I will explain that later. Well, since it's a prototype, I implemented it using Ruby, since Ruby is a quite good prototyping language, but it's extremely slow. Cinderella currently does the detection process with about 12 to 13 kilobytes per second. That's extremely slow. And well, it should work on any platform supporting Ruby 1.6 something, and the Ruby PCAP bindings. And the further goal is, of course, as soon as it's stable and mature, it shall be re-implemented, preferably C and the NoFap library. I think that will gain quite a lot of speed. And of course, algorithms and data structures must be optimized. They're currently well, every list is going to be, or is rebuilt several times in Cinderella, so this takes quite a lot of time. So, why the name Cinderella actually? I will shortly explain that. Cinderella is the English version of the well-known tale Aschenputtel by Brothers Grimm. And this tale contains a quite famous quote that very well describes what Cinderella does, a network intrusion detection system. And that is, the good into the pot, the bad into the crop. Cinderella only separates good traffic from bad traffic, and it doesn't do anything more. And well, the algorithm is pretty simple. The Ethernet frames are sniffed off the network, and packets other than IP packets are discarded. Well, not discarded in the network, but internally. Other protocols than IP aren't implemented yet on that layer. And well, TCP, UDP, ICP, and other packets are separated, and TCP packets are reassembled to the stream of the connection. And well, it is done by looking at the source IP, source port, destination IP, destination port, and that's what identifies the connection. And then a conversation is built from the connection. A conversation is, well, what the payload on TCP actually is, and what to send each other. It's simply an array containing what the client first sent, and then the server, and the client and the server. And then this conversation is evaluated by a module, a module is associated with a certain connection or a number of connections in the configuration file. So in the configuration file you can use regular expressions to associate them. I will show it later. And well, when a connection is identified as either good or bad, it is marked as such and written to the corresponding TCP file. And well, when it can't be identified as either good or bad, so unknown, it is that the connection is then re-evaluated when the next packet arrives. And well, connections that aren't explicitly configured in the configuration file are automatically bad. That's the indubious contrario. Well, implementation of UDP is similar. It's of course easier than TCP, that since only single packets have to be analyzed and not the whole connection. And modules for most UDP-based protocols can be implemented using stateless logic. Some cannot, but since hardly any modules for protocols are implemented, I didn't have this challenge yet. Well, ICP is a little bit different. You define policies for ICP packets instead of modules, and these policies define which hosts may send which ICP hosts to which hosts. Of course, ICP packets without corresponding policy are again bad. Well, that's an example configuration. First, you have TCP, and then you give the module to load, and then regular expression that describes the source IP and the source port, and then the destination IP, destination port. Very important is the caret at the beginning and the dollar at the end. Also, it's matching somewhere in the middle, and well, that could lead to evasion. The configuration for UDP modules is similar, and ICP policies are no port, of course, and then at the end you have a list of allowed ICP codes, echo reply, whatever, and you can optionally also add two-way or one-way, which says well, two-way says that source IP and destination IP are interchangeable, and that ICP packets from one host to another and from the another host to one, both match this policy. Well, a simple example there, HTTP module, including comments and blank lines, 25 lines or so. I was able to put it on 2 slides. First, you have a function to initialize it. You don't, well, first have to describe how the HTTP module works. It simply has a list of working expressions of allowed, get, or post, or whatever requests. So this stuff, the headers from post requests aren't checked yet, but it's a prototype. Well, this list of regular expressions is loaded and put into an array. And then the evaluation method simply checks whether the conversation already contains one element, which when it's HTTP, it's to get a post request or whatever. And then it checks the list of regular expressions, whether it finds a matching regular expression, and then it returns. As soon as it finds one, it says yes, it's evaluated, and yes, it's good. When it doesn't find one, it says yes, it's evaluated, but no, it's not good. And then when it doesn't find, when the size is 0, it says no, it's not evaluated, and the second element is ignored. Well, example for the HTTP module configuration file. Well, get requests described by regular expressions. Not really exciting. And scripts to auto-generate these configuration files can be easily written. You could protect your HTTP server and then surf around a little bit and then run a little script on the access log. And then it could generate these regular expressions. Already wrote this for the predecessor of Cinderella, which was non-free and within 50 lines of code, so not really difficult. So I will tell a few things about Cinderella in practice. How does it handle port scans, and how do Cinderella's concepts make it possible to detect these HTTP wars like code red and other similar wars in the future. Well, TCP connection attempts that are explicitly defined in Cinderella's configuration are marked as bad, either because they are reset or because, they are defined as bad anyway. In case they are defined, the connection is either reset or closed with a sending and payload, or it times out, and so this traffic is marked as bad. And so port scans are not explicitly handled, but assume one does a port scan and does a simple connection scan, and you have a lot of resets and connections that reset. They are all marked as bad, and when half-open scans are done, these connections are then reset too, or timeout, or whatever. They are not detected too. And that's in dubio contrario. And in practice, packet filters are placed in front of a publicly accessible network. So you usually have a deep set or something. Usually port scans don't even reach the NIDS, and it also lowers the number of potential false positives in case something is wrong with the NIDS. Okay, how do Cinderella's concepts make it possible to detect code red, indent, other similar ones? Well, you all may remember code red and Nimble, and they exploited in some buffer overflow in Microsoft IaaS and some other several variations of code that existed with different padding characters. Version 1 had N and version 2 had X. And Cinderella's HTTP module only marks HTTP request is good. That are explicitly defined, as I showed before in the example. And I think it's very unlikely that an administrator of a network intrusion detection system defines some worms exploit strings as allowed HTTP requests. That's very unlikely. Well, may happen, but then it's of course the administrator's fault. And Cinderella can't help either. So again, this injury counter-radio concept. And of course, this concept must be enforced by each module. So as soon as one module is used that doesn't enforce this concept or this strategy, well, Cinderella can be evaded even easier. Cinderella may act as a wrapper, as I mentioned before. Since Cinderella is intended to separate suspicious from unsuspicious network traffic, it can, for example, discard the unsuspicious network traffic since it's not suspicious and we're not interested in anymore. We do not invade our users' privacy. And then the suspicious network traffic can be looked at, for example, using another network intrusion detection system like Snort, since it mostly does misuse detection using patterns. And it really has a quite good set of patterns, but well, the smart people say that they also do other things like anomaly detection and stuff, but in practice I only see those Snort installations using the patterns and no advanced stuff. Okay, then, but you can then configure Snort to discard all the traffic in which finds a known exploit string or pattern. Since it's already known, you can discard it, and you have protected the system against it anyway, haven't you? Okay, what is left should then contain previously unknown exploits and attacks in case Cinderella works correctly and Snort works correctly. As you see, I went through that way too fast. Well, drawbacks and possible evasion of Cinderella. I think every producer or vendor or every NIDS project should be honest about what their network intrusion detection system is capable of, and what it is not capable of, and what its disadvantages are. And here I will present the disadvantages of Cinderella. It's currently a prototype, so it's absolutely not usable in production environments. For example, IP fragment reassembly isn't yet implemented. It's really a crucial feature because it could easily lead to evasion. It already has, I think, some one of these home garages you get for, I don't know, 200 euros or so. There have been several exploits to bypass. I think it was a packet filter or something. Don't exactly remember anymore. It was inside the router. And well, the TCP state machine is working, but not 100% perfect. That is really something that changed within the last 1 or 2 weeks. Because before that I had my very own CCC state machine, which was totally broken. Then I ripped out Smart CCP state machine, imported it to Ruby, and it works quite okay. And it's faster than mine. Modules for a wide range of protocols are still missing. What would be interesting is SSH or FTP, which would be quite difficult to implement since you have usually when you do active FTP, you have 2 ports and 2 connections, and can be a challenge. DNS would be interesting to look at. NTP, all the crucial stuff. Currently, modules for HTTP, SMTP, and POP3 exist only for testing purposes. That's not really a lot. And of course, you're all invited to try maybe Cinderella and help improve it. I will show my email address later for my reports. Okay, you can get Cinderella from developer.belarus.de/project/Cinderella. I have CVS set up there. Just check it out and play around with it. And some little bits of documentation, general information in a paper. You can find out at synflat.at/Cinderella. And of course, comments are welcome, claims are not. They will go to DevNow. So, I'll finish that really quickly, and so we have a lot of time to ask and answer questions, and here again, the most important URLs and my email address. So, are there any questions?
How is the suspicious network traffic displayed? How can the information about the suspicious network traffic?
Currently, Cinderella only separates the traffic to either good or bad, and it saves it in TCP dump files. So libpcap has some portable file format where you can dump network traffic to, and it's the easiest way for saving network traffic, for debugging, and I think that's how it will be done later too. Maybe it will be directly piped to some other program or whatever, but that's because of the prototype step. Did that answer the question? Okay.
Are you afraid of the availability of the system this year, because this tends to block all unknown traffic, so you get integrity but you lose the availability perhaps? Are you worried about that? And another question is that you are parsing all the packets that are coming in, so are you worried about the vulnerabilities on the parsing code, because it might give the attacker a possibility to exploit a critical point in the network?
Yeah, you're absolutely right. The packets have to be parsed, and I think you in some way you have to look at the traffic, and that's always a vulnerability in every network intrusion detection system, and that has to be implemented very carefully and checked very carefully and audited and re-audited. And I think that's all I can do when I implement the concept that I have in mind.
Yes, the way you ran your project, was it a specific choice to first implement a prototype in Ruby and then later on do it all over again? Or was it something you came to along the way?
Well, first I got the idea when I worked at an Austrian security company for 4 weeks, and some guy said, hey, now start you play with the pcap and try building a sniffer and then building maybe a simple network truth injection system. And it was quite easy to implement. And so I continued the work that companies bankrupt, and I simply wanted to redo everything, and I said, let's do it how you learned it in software engineering and do it first to a prototype to have a look at how it can be done, and for, most importantly, not to do the mistakes again that I did in the very first version. And well, currently I'm in the prototype state, and well, I don't exactly know when I will re-implement it. Might be quite far away. So.
How do you think about using honeypot technologies like hogpodge or something like that? Is it possible with Cinderella? Do you think that makes sense, or not?
Well, Cinderella is not really designed to do this detection process in real time. I explained that at the beginning of the lecture. So I think honeypot technology, well, would be nice to integrate, but can't be done since it's not in real time. We would also thought about that in the very first version, but that's also quite a lot of work, but in theory, not. Well, it depends how fast the re-implemented fast version will be. And then it might be possible, maybe, but I wouldn't trust on that. Because when it has to be done in real time, it's a target for denial of service. Just giving, high number of connections, and then everything takes a little bit longer, and then you can't keep up with the network traffic anymore, and then the detection system is invaded, and that traffic is not led to the honeypot. Does that answer the question?
Yes. But basically, you think it would be useful using honeypot technologies, but only if your program is fast enough to do that.
Yes, and to be honest, I don't think it will be fast enough.
Okay.
So.
What about the license stuff on the hardware side of GPA? But
Yes.
You also told about non-free parts in your presentation. What's not that?
Could you repeat the second question?
Yeah, there was something about non-free additions or parts in your presentation, I think.
Okay, the non-free predecessor is the thing that I implemented at the Austrian security company. I don't have any source of that anymore, and forget it. I re-implemented everything by scratch, from scratch, and I put it out as a GPL, but if I don't know the OpenBC project is interested in it, I think I can do a fork for them and give away the sources on a BST license. But basically it's GPL, since I believe in that license. Any other questions? We still have enough time for questions. Yeah.
How does the system learn about new policies? I mean, you said something about for example, the Perl script that you could run to it work?
It all has to be configured by hand. So you should have policy what traffic is allowed to your systems and from the systems, and based on these policies, you could build up your Cinderella configuration. And I don't think I will automatize generation of configuration file.
So you could say that Cinderella is kind of a reverse snort, where you just, I mean, you don't mark, or you don't have patterns for bad traffic, but you have patterns for the good traffic in discard all the other stuff.
Yes, in some way. In Dubu ProRay, as Snort does it, and Dubu ConfigurAI as Cinderella does it.
Okay, thank you.
Any other questions?
Have you thought about using the Snort engine? Just don't put any rules for the bad traffic, but for the good traffic to get rid of the speed problems?
I already thought about it, but I once came up with the idea, but I didn't have a further look at Snort yet. And, well, it might be possible. Well, I already, when I worked at the first version, I had a closer look at Snort, and I didn't like the source code very much. It all looked like it would fall apart or something. But that's only my personal opinion.
Did you consider other specification language other than regular expressions?
Please repeat that. I didn't understand.
Did you consider other specification languages?
Other specification language than regular expressions?
Yeah.
No, not in the current state. Well, I think regular expressions are powerful enough to describe the connection, the module configuration. It's not really difficult to learn, and you can do a lot of things with these regular expressions. And they are also quite handy for the HTTP stuff. So maybe for future modules, there will be other specification languages, but not in current state. And well, I just like the regular expressions because it's pretty simple to use them. Any other questions? Yeah. Over there?
Do you have any performance numbers? Because I'm interested in interest values in Ruby, how much throughput you can achieve on a machine.
I did a few benchmarks, and it's about 10 to 13, 14 kilobytes per second that are currently evaluated. So this shows disadvantages of scripting languages. So really slow.
What kind of system setup?
I think exactly one HTTP module and one async policy or something.
The hardware setup.
Okay, the hardware. I tested it, I think, on this iBook 800 MHz G3. Any further questions? Yeah, okay. If there are no further questions, we'd like to say thank you for had a lot of fun with the other lectures. The next one should start in 15 to 20 minutes.